Dear students, this is Naresh Reddy along with Naveen sir. Today we are going to let you know what is the importance of communication system subject in various competition exams. Please Naveen sir.
Communication systems plays a dominant role in all the competitive exams. It's a very important subject in electronics and communication engineering branch. So if you see this subject in all competitive exams, there is a good weightage is present. So for the GATE, it is having an average of 12 marks is present from all the previous years. And if you see this subject in ESE, for the prelims we are getting 20 to 25 marks on average. And when the pattern was changed, they are going to be increase the weightage also. And for the conventional part, we can going to be find out such that it is having approximately from 50 to 60 marks has to present in the conventional part. So it is also plays a very important weightage is present in all the PSUs such as ISRO, DRDO, and for the BEL, we can find out a good weightage is present. So it's a very good subject where we can going to be score more number of marks for the rank improvement in all the subjects. Okay.
A communication is basically transmitting a signal from one place to another place. Actually, we can transmit the signal in analog form and a digital form. In the process of transmitting in analog form, we come to know about analog communication. In analog communication, the foremost topic will be the amplitude modulation. Actually, in transmitting the signal in analog form, the modulation techniques will be used. The first one is amplitude modulation. This first unit amplitude modulation is giving in GATE examination average of 1 to 2 marks, and in ESE prelims also you can expect some 2 to 3 marks you can expect. In amplitude modulation, mainly you have to focus on what is the time domain equation of different modulation schemes like AM, DSBSC, VSB, SSBSC. So what will be the time domain expressions for these modulation schemes, and you have to know about spectrums of these modulation schemes, and finding the parameters like finding bandwidth and finding power and finding power efficiency, and these parameters you should be very good with, because based on these parameters only generally you can expect questions in examination.
So coming to the next topic in communication systems, it is frequency modulation. So if we talk about the frequency modulation, the major drawbacks of AMs can be overcome in the frequency modulation. If you come across the frequency modulation, so if you see that there are two types of frequency modulations are there. The first one is NBFM and the second one is WBFM. But we are more focusing elaborately about the WBFM concepts in communication system. If you talk about the WBFM, we can see the time domain equation, and we can go for the spectrum analysis of WBFM, and after that we can calculate the power calculations, the bandwidth calculations of WBFM, and what are the various applications of WBFM, and what are the requirements for generating the single tone WBFM and the multi-tone WBFM. So after that we are going to be discussing about the generation and detection techniques of FM. So where we can study both NBFM and WBFM in that part. But most of the questions that come in the GATE are especially they are concentrated on the calculation part, the parameter calculations of NBFM and WBFM they are using. But mostly what they do means they will cover some parts of AM will be covered in the FM also while covering the questions in the GATE. So coming to the weightage of especially this chapter, in GATE we are having some 2 to 3 marks are present, and for the next one such as ES for the prelims we are getting from 2 to 3 marks in the objective part, but the remaining things for the conventional part of this chapter we are going to be expecting one question, that is mostly that question will come from the numerical type type of question in FM using the WBFM concepts only, calculating such as frequency deviation, modulation index, bandwidth, and some parts of changing the parameters of the message signal. Those things will be going to be mostly asked in the conventional part. So please Naresh sir, the next chapter will be discussed by yourself.
The next important topic will be receivers. Here we are going to study about the types of receivers like TRF receiver and SHD receiver. TRF receiver actually having some problems, having some drawbacks. To overcome these problems, we go for SHD receiver. In SHD receiver, we study about AM receiver as well as FM receiver. And one important thing here is you have to know about broadcasting standards. Some standards are there for AM and some standards are there for FM, like what should be the AM bandwidth and what should be the FM bandwidth, and what is intermediate frequency for AM and FM. Like some broadcasting standards are there, and you have to be good with the broadcasting standards. And in the discussion of super heterodyne receiver, you have to know about the concept of intermediate frequency and about image frequency, because in most of the competition exams you can see the question on finding image frequency. So image frequency is the important topic in receiver section, and finding IRR, another parameter is there, IRR, image rejection ratio. So you should be good with that, finding IRR also. And one topic is there, that is pre-emphasis and de-emphasis. That is also one topic you have to be focused. And the next one is FM receiver. FM receiver, how the operation of FM receiver is different from AM receiver. You have to know these things. And in conventional paper, generally they are asking the working principle of super heterodyne receiver. So you should be good with what is the operation, what is the flow in SHD receiver.
Still now we discuss about all the topics of analog communication systems. Now we are going for the second part, that's the digital communication system. All the requirements of our communication systems cannot going to be met by the analog communication. So we are shifting from analog communication to the digital communication. So once coming to the digital communication system, first of all we have to study about the basic principle of sampling. So how sampling was done, what are the different types of sampling. So what's the Nyquist rate and why the oversampling is only preferred in communication systems. So these things we will study in the starting part, before starting the digital communication part. That means we concentrate on the sampling, and we also introduce about the bandpass sampling here, where the bandpass sampling and how to calculate the Nyquist rate of bandpass sampling can be studied. So after the completion of the sampling, we go for the baseband transmission. So entire digital communication is divided into the two parts. So one is called as the baseband transmission, and the second part is the passband transmission. So I can discuss about the baseband transmission right now. So if you talk about the baseband transmission, the transmission without modulation. So once we talk about the transmission without modulation, means it comes under the category of the guided transmission. So we can discuss about the different types of the guided transmission. So we can talk about the types of baseband transmissions. In types of baseband transmission, the first important one is the PCM, which stands for pulse code modulation technique. So in PCM technique, we see about how we convert analog to digital, and again we can convert how the transmission has to be done, and again how to convert from the digital to the analog. So that's the major thing we concentrate in the PCM technique. So for that PCM technique, the important things are parameters of PCM. In that we can give the most importance for calculation of bit rate, so calculation of your quantization error, and also for the calculation of your bandwidth by using the bit rate. So after the PCM technique, the major thing that we can find out in the PCM technique is, the drawback for that PCM technique is it is utilizing more amount of the bandwidth. So that to overcome that problem, we go for the remaining techniques called as the differential pulse code modulation technique, which is called as DPCM. So in the DPCM technique, we can overcome the drawback of PCM. but designing issues of DPCM will make us to learn about the more techniques of baseband transmissions, such as delta modulation. If you talk about the delta modulation, which will save the bandwidth, and that is going to be having a fixed step size, and we can study about the parameters also here, and we can concentrate on the signal to quantization noise ratio calculations in PCM as well as in delta modulation. So next one is the ADM, adaptive delta modulation, which overcomes the problems that we are facing in the delta modulation, and it is having a variable step size, so it's called adaptiveness, where you can have to change it. So that is the next important thing we study in the baseband transmission. So coming to the weightage point in the gate, they are going to be using these concepts mostly to make the basic things in digital communication. So the weightage was going to present as 2 to 3 marks we can have on average. So coming to the ESE part, for the prelims they can going to be asking you the questions, such as we are going to be having 2 to 3 questions will come. That means the average marks will also be from 4 to 5 marks we can have in the prelims, that is in objective paper. And when you come across this subjective paper such as conventional, what you call so-called conventional in the mains, most of the questions they ask is, first they can touch the parameters, one numerical will be asked in the PCM, and they can talk about the signal to quantization noise ratio derivation for the PCM. It's a very important thing asked many times in the conventional part. And next you can talk about the operation of delta modulation or operation of the DPCM or principle of the DPCM, they can ask it in the conventional paper. So if you see that we can have the baseband transmission, definitely you can expect one question in subjective paper in engineering service exam. So about the passband transmission, so Naresh sir will going to be explaining to you.
Yeah. In bandpass transmission, we are going to study mainly about the binary signaling modulation schemes and MRA signaling modulation schemes. In binary signaling modulation schemes, we study about ASK, PSK and FSK. Actually, these modulation schemes are mainly used to transmit the binary sequence through free space. So we are going to use these modulation techniques. And in these topics, we have to study like how to generate these signals ASK, PSK and FSK, and how to demodulate, and finding the parameters like what is the bandwidth of these modulation schemes, and you have to know about constellation diagrams also, because in competition exams they are asking questions based on this concept of constellation diagram. And about FSK, one important classification is there for FSK, like for coherent FSK and non-coherent FSK, and what are the conditions to be satisfied for FSK to be coherent and for FSK to be non-coherent. And based on this, the questions are giving. Even 2 years back in GATE examination, a question was given based on this concept of coherent and non-coherent FSK. And about these modulation schemes, you have to know, like they are asking finding probability errors of these modulation techniques also, bit error rate or probability error of ASK, PSK and FSK. And this topic of finding probability error is mainly you can see in conventional paper. They are asking a question like finding probability error of these modulation techniques. And if you come to MRA signaling schemes, here we are going to see like the QAM and QPSK and 4 array PSK, 8 array PSK, and we have to know about these schemes. And here also the same thing, you have to know like how to find bandwidth of these modulation schemes and bandwidth efficiency of various modulation techniques, and finding the probability error of these schemes. So you should be good with these things.
So the next topic is information theory. So if you talk about this information theory, which is going to be the basic part for digital communication system. So we can talk about what is the information and what is the average information, and what is the relation between this information and probability, and how that probability will going to be useful in giving the reduction in the bandwidth of the digital communication system. So next important thing that I want to talk about this information theory is we are talking about the bit rate. So the bit rate and the bandwidth, obviously we studied the relation between those two things in the previous topics. From those we can going to be utilized here. How that bit rate will be reduced and how bandwidth will be reduced studied in the information theory. So talking about the sources, there are two types of sources. One is discrete memoryless source and discrete memory source. In the entire communication system, we are concentrating on the discrete memoryless source only. And we can talk about that how the discrete memoryless source, how the calculation of the discrete memoryless source, how we convert that symbol into an code word will be studied by using an source encoder. So there are two types of source encoders, that is, one is called as fixed source encoding technique, where your probability is fixed for all the symbols, and second one is variable source encoding technique, where the probability is going to be changes, that is, for each symbol the probability is not same. So second important thing is we can talk about variable source encoding. Mostly we can study about variable source encoding, where we can find out that entropy will be become minimum. So if entropy is going to be the minimum, means obviously the bit rate will also be going to be the minimum. So there are two types of variable source encoding techniques. The first one is Shannon-Fano coding technique and the second one is Huffman coding technique. So after the completion of this information theory, we are going to be discussing about the error controlling codes. The one of the beautiful advantage of the digital communication system is it must be having an error correction and detection. So we are going to be discussing about that how the error correction detection will be done. So the basic principle of redundancy will be studied in the classroom, and after that we can talk about that the simple error correction detection is the parity. So even parity and odd parity, how they are useful in find outing the error. So after that we see about the different types of codes, that is of linear block codes, okay, and conventional codes will be studied in the classroom. So one of the linear block code was the codes we are going to be having other cyclic codes we can study in the class, and we can also see about the Hamming codes also. So these things we will discuss in the information theory. For this, there is a two parts of information theory, club to combined to called as an information theory itself only. And next coming to the weightage of information theory in GATE exam, that is going to be having 3 to 4 marks. And for the ESE, the weightage is going to be having say as 4 marks or maybe greater than that also for the prelims. And for the mains, that is for the conventional part or subjective part, I can definitely tell we are going to be having one question of numerical will be asked based on this Shannon-Fano Huffman coding in source encoding technique, or maybe an error correction detection technique. One question they will going to be asked, and this is the important part in communication system, where most of the questions are covered in these parts in the competitive exams. So the next topic was going to be the part 3, where Naresh sir was going to be talking about that noise part.
And a very important topic for GATE examination will be the random variables and random process. From last 4-5 years, the most of the questions are given from this topic. Almost 5 to 6 questions every year you are giving from this topic, random variables and random process. In random variables, the basically two types, discrete and continuous random variables. And for better understanding about random variables, some special functions are defined for a random variable, like probability density function and probability distribution function. And here we are going to see what are the properties of density function and what are the properties of distribution function, and how these will be related to each other, and how density and distribution function will be defined for a discrete random variable and for a continuous random variable. So these things we are going to study. And one more thing is finding entropy of a random variable. So this is also finding entropy of a discrete random variable and continuous random variable, and what is the conditions to get the maximum entropy for a random variable. So these things also you have to study in this topic. And some statistical parameters also there in the analysis process of random variable, like mean square value and variance and standard deviation, and we have to know about these parameters. And some standard probability density functions are there, like uniform density function and Gaussian density function, the Rayleigh density function, and we have to know about what will be the expressions for this density function and what are the properties of this density function. And for the competition exam point of view, the Gaussian density function is the most important density function, because in noise analysis, okay, this density function is going to be very much useful for us. So that's what for Gaussian density function, what will be the expression and what will be the statistical parameters like mean square value, variance for Gaussian density function. You should be very good with this. The extension of random variables, we are going to study about random process. In random process, first we have to start with the types of random process, the main types of random process, like wide sense stationary random process and strict sense stationary random process, so WSS and SSS random process, and we have to know about this. And what is the concept of ergodicity in random process, and how to find the mean and autocorrelation function of a random process. Actually, this is the very important topic in random process, I feel, because in GATE even you can see the questions like finding autocorrelation function and finding the mean of a random process. And in the process of studying about random process, you have to know about autocorrelation function, and you have to know about power spectral density and how these will be related to each other, because nowadays in GATE examination, it's became a compulsory question, like based on autocorrelation function and power spectral density, how these will be related. And another important topic is if you pass a random process through LTI system, okay, so how random process is going to be affected when you pass through a system, like if input mean is given for a system, then how to find output mean. If you know input ACF, autocorrelation function, how to find output ACF. If you know input PST, how to find output PST. Like this is I feel it's the most important topic, I feel like, because it's really became a compulsory question nowadays in GATE examination. And how to find power from PST. This PSD, the properties of power spectral density, and passing a noise through a system. Noise also can be visualized as a random process, like you can see as random process, like passing a random process through a low pass filter or through a band pass filter. Then what will be the output parameters. So you should be very good with these things. And in information theory, some second part also I can see this is a second part, like in information theory, like Naveen sir already told about information theory, some topics, and some as a second part in information theory, you have to study about the input probability matrix and output probability matrix, and conditional probability matrix and giant probability matrix, and how these matrices will be related to each other. So you should be very good with this. And you have to know, like different types of entropies also there, like giant entropy, conditional entropy, and some formulas will be there about entropies, means how these entropies will be related to each other. And types of channels also there, like binary symmetric channel, binary asymmetric channel, and lossless channel, deterministic channel, and noiseless channel. You have to know about these channels. In the recent GATE examination, like 2 years back, he was given a question about the channel, like he given some information in the question, and you have to identify that is related to which channel. So you should be good with the classification of channels. And one more thing is, one important topic in information theory is Shannon-Hartley law. This Shannon-Hartley law will gives you the relation between channel capacity and channel bandwidth. Means if the channel bandwidth and signal to noise ratio is given, then how to find channel capacity. This is the important topic in most of the competition exams. Even in ESE prelims also, most of the times the question was given how to find channel capacity. And mainly for AWGN channel, actually additive white Gaussian noise channel, how to find channel capacity. And for AWGN channel, as bandwidth tends to infinite, so what the channel capacity becomes. So this is also the important topic you have to focus in information theory. And I can say the information theory, random variables and random process, these topics nowadays became very important topics for GATE examination. Almost 6 to 7 marks you can expect from these topics. So you should focus very much on these topics.
So coming to the next concept, that is the noise. So noise, basically any unwanted signal is considered to be as a noise, and that noise is of two types. One is internal noise and another one is external noise. So we can mostly concentrated in the narrowband noise in our noise part. There is the equation for narrowband noise, and how that additive white Gaussian noise was affecting on a signal while transmitting into a channel. We can study in the classroom. And after that we will show that the impact of our transmission of your signals in the noise environment will be studied as a concept of effect of noise in analog communication, where we can going to be calculate the figure of merit of each receiver and how they are going to be working in the noise environment. And we are going to be concentrated mostly on all the modulation techniques such as amplitude modulation, DSBSE, SSB, and we can talk about FM, both NBFM and WBFM, and as well as for the PM. So where we are going to be discussing about the figure of merit in noise in analog communication. And after coming to the noise in digital communication, as we studied previously about the baseband transmission, we talk about signal to quantization noise ratio in PCM and signal to quantization noise ratio in delta modulation. Now we are going to be concentrating mostly on the noise in the passband transmission. So before going to talk about the noise in the passband transmission, we want to tell about that how your optimum receiver can be designed. And for that we are going to be talking about a filter. This filter is said to be called as a matched filter, and that matched filter was going to be useful for us for increasing the signal to noise ratio at a maximum. So when signal to noise ratio was going to be maximum, the effect of noise will going to be less. So such type of optimum receiver can be designed with introducing the concept called as matched filter. And after that we will see about the probability error calculations on the effect of the probability error calculations, probability of error in each modulation scheme present in the digital communication systems, such as the ASK, FSK, PSK, and about the QPSK. We will study in the classroom about all these things in detail. After that we will talk about the coding technique, the decoding technique. One is called as MAP and ML, which stands for maximum a posterior and maximum likelihood. For that we can study in the classroom how these techniques are useful for us in the analyzing the performance of the receiving system, so that the probability of error was going to be decreases. So that we can going to be discuss in the classroom. And after that we will talk about the basics of the some multiple accessing techniques in communication systems, which comes under the application part. We will study about one application. Up to now what we studied in the classroom, we can make one application. That application is going to be using as a multiple accessing application in satellite communication, such as the TDMA, the FDMA and CDMA. So where we discuss about all these multiple accessing techniques in the classroom. And after that I want to talk about some other the concepts such as the intersymbol interference and the synchronization of your transmitting and receiving section, how the effective synchronization can be obtained by transmitting a signal from transmitter to the receiver in a communication system we can study. So this is the complete syllabus present for the communication systems in engineering service exam and as well as in the GATE. But what we discuss about all the concepts are exclusively for the GATE. And for the ESE, the part of random variables, random process and noise part was going to be very less weightage will be given in the engineering service exam. the number of marks that we are getting in these things are 1 to 2 marks only on a maximum in the prelims. But we can expect one conventional question from these topics, especially they are going to be asking with the figure of merit calculations or the probability error calculations as a conventional question. And coming to the remaining things about this basics, the basics of TDMA, FDMA and CDMA, the questions that we are asking are very less in the GATE. Okay, that too they can ask in the CDMA only. They are going to asking about the CDMA part of numericals can be appear in the exam. So this was the complete syllabus that we are going to be handling in the classroom. So in the classroom, every concept will be going to be taken in detailed, and we are going to be explain each and everything for your all competitive exams. And the textbooks that we are referring, and we are going to be talking to the students for the further reference for this subject for communication systems. So the first book is Analog and Digital Communication Systems by Simon Hykins. Okay, and the second book is going to be the Analog Linear Systems and Communication Systems by P.P. Latti, which is the second good book we are having. And Analog and Digital Communications by Sham series, that is the other issue HSU. The Sham series is going to be the good book where we can practice more number of questions, more model of questions will be covered from that book. And these three textbooks, what I told up to now, are for the GATE students who are appearing for the GATE exam, and that is also useful for the engineering service also. But for engineering service exam, which is going to be the preferred book, is the Electronic Communication Systems Fundamentals through Advance by Van Tomasi. So which is a very good book where elaborately we can going to be explain about the analog and digital communication systems, and also the advanced parts also be present in that book, which is most important for the preparation of ESE.
Dear students, my suggestion is first you have to be very good with the classroom notes, because in the classroom we are going to teach from very basic level to the advanced level where you can attempt every possible question in competition exams. So first be good with the classroom notes, and even you have to go for multiple revisions. So repeating the things again and again and again will make you perfect definitely. So the repetition you have to do definitely, and the periodic repetition is also very much required, because you should be in good contact with the subject. So if you don't go for revision, so you will lose the contact with the subject. So go for periodic repetition. And one more thing is, you should be very good with the what actually the syllabus is given. So you have to see what topics are given in the syllabus. So try to stick to those syllabus, and don't go for multiple sources. So try to stick to yourself, like what you have to study, and be perfect in those things. If you feel you are weak in a particular content, then for that particular content go for any standard textbook and try to be perfect in that particular content. And one more thing is the assessment of yourself. Assessment is of yourself is very much required. So for this I suggest to write a mock test. So MEDESE is offering almost 60 to 70 mock test. My suggestion is don't underestimate this mock test. You have to write, because by writing this mock test you come to know how you are managing the time, means how many questions you are able to answer within the given time, and how much accurately you are giving the answers. So you come to know that, and what is your position, what is your rank, means this test series will be conducted all India wise. So you come to know where you are, whether you are in the competition or not, in which, what are the areas you looks to be weak, means from which topics you are unable to answer the questions, and once you identify your weak topics, then you can concentrate on those topics, and that is going to be definitely very much helpful to you. And one more thing is, in the GATE examination, don't go for wild guesses. So you should be very accurate in giving the answers, then you become perfect. So don't go for wild guesses, and be accurate in giving the answers. And one more thing is, if possible, go for a group study also. Find like-minded students and try to go for group studies, so that you come to know the different ways to solve a problem, and that will definitely increases your efficiency in solving problems. And one more thing is the self-made notes also important. Try to make a short notes like, okay, with your handwriting. That is definitely going to be very much useful to you in the last minute revision. And one more thing is, if possible, try to go for the shortcut techniques in the GATE examination, because the time management is very much important in GATE examination. Attempting 65 questions in 3 hours is not that much of easy, so you should be go with the shortcut techniques, and the time management and accuracy is definitely going to be very important to crack the GATE examination. And one more thing is, you have to know how to use virtual calculator in writing GATE examination. You should be good with that. And for ESE also, for ESE mains, ESE the repetition is happening, like some questions you can see repeatedly in ESE prelims and mains, and you have to solve last 10 to 15 years of mains paper, conventional paper, and you have to get habituation of writing the answers for the question. And if possible, try to find some mentor who already cracked IES, who already cracked ESE, so that he will give very valuable inputs to you, because he already cracked the examination. So his suggestions are going to be definitely helpful to you. So if possible, try to find a mentor and take the suggestions from him. And if you write any mock test for conventional paper also, try to show that to your mentor, so he will give you the suggestions like where where you can improve, and how to change your writing styles, writing skills, like, so those things are definitely going to be useful to you. And come to Made Easy, and you are going to get all possible inputs and all possible help from our side, and you are definitely going to be very good with the subjects at the end of the course. At the end of the course, you are going to be in a position to solve every possible question in the competition exams. So I'm welcoming all you to come to Made Easy, and all the very best.